Yeah, Assalamualaikum warahmatullahi wabarakatuh. So I will start with the first lecture for this week. Okay, so this will be like an introduction or the overview of data communications overall. So I would like to brief a little bit or refresh back again everyone's knowledge about data communications. So so what will be the objective or the contents is that um, you should be able to elaborate the components of data communications, list the effectiveness of data communication system, and then explain the type of data, elaborate directions and transmissions mode of data, and then explain the standard and protocol. Okay, um, so the data communications and networking have changed the way we do the business or on our daily life. So the decisions can be made as fast as possible. And sometimes it require immediate access to accurate information. So usually previously on the older one before the starting of the internets, okay, we use a mail, but now because of the internet, the emergence of the ICT, okay, we are able to have the information or the mail, the emails that we require from outside, from over the sea. Okay, so to be able to reach it instantly. Okay, so but the business or our operations daily requires that we have some networks and internet works. Um, the data communications are very important elements that enable the information to be shared. So it is very important to understand the concepts and mechanism of these technologies, what they do and when to use. So although we have the emergence of the all of the technologies available so far, actually they are based on what we have from the foundations of the previous or of the current of the previous technologies actually. So this is where you need to learn about this part. So what is the data communications? Basically it's very the same thing um, over the time, whatever the applications that we have or whatever technologies or um, methods or communication. So basically, we have the data communication must have an exchange of data from the two devices, whatever devices that we have so far. Previously, maybe the computers, but now we can have the PCs to the phones and vice versa. So it must have some form of transmission medium. Okay, so data here is the concepts and instructions presented in whatever form agreed upon by the parties creating and using the data. So in this case, if we are using like teleconferencing, like a video conferencing, so the data itself is the video or the pictures or the moving pictures as the data, and also the audio of the audio of the speaker that would traverse from one side to another side. Okay, but then what type of transmission that we will use? So either it's a wired or wireless. So the communicating devices are part of the communication system made up of two, hardware and software. So you still need a hardware like a medium that helps you to capture the information and then transfer it. Okay, so one is the edges, as I call it as an edges, it's because of that's the end of the network. Each network means that something can be a computer, a server. Okay, so we will require some computers or maybe mobile phones, okay, laptops, okay, for you to use as a communication. And then we have the intermediary devices, which means from the computer, where do we want to connect to? Okay, because we want to connect to the internet. So let's say it's inside the on the companies or on the universities. Okay, so you need a large local area network. So you would need some intermediary devices to connect each of the computers or other networking devices. So here we will have switch, hub, or router. And then when you go out means that publicly available to the internet, then you would need to use the modems, okay, and then the lines, the fiber, okay, so that's the hardware. So it doesn't have to be a devices. Sometimes it can be the cabling and devices that connecting the cables, okay, and then software. It's also part of the communication system. Let's say if we want to use emails, then we use my email applications. And then let's say you want to access a server, a web server, then you need a web browser. Okay, and then if you want to chat, you use WhatsApp, Telegram, and then if you want to use video messaging, so there's a different type of applications, right? To suit, okay, the type or the functions, okay, for the communication, right? And then okay, so what are the components for the data communications? Okay, one is that you need a sender and a receiver. Okay, regardless if there's a lot of receiver or there's a lot of sender, but still you need sender and receiver. And then you need a medium here. Okay, so you need a medium that would enable you to send the message. So in order for you to send the message, you will need a protocol. For example, if you want to access a web server, so what type of protocol that you require? So you will need HTTP. But then if let's say you want to send an email, then you will need a protocol such as an IMAP, POP3, okay? So we have five here: protocol, message, medium, receiver, and sender. Okay, so message can be the information to be communicated, such as a text, numbers, pictures, sound, video, or maybe a combination. So sometimes you will send a files, or sometimes you will send a an executable file, or maybe a videos, okay, on that message. And then sender, the device that sends the message. So some devices, maybe your phones, your computers, okay, video cameras, workstation, or maybe server, okay. So the receiver can be a computer itself also, maybe can become the server, your handphones, video cameras, okay, so anything that is under the edge device, and we call it edge device. Okay, and then medium. Medium is the physical path for the transmission. When I said it as a physical path, okay, it can be the copper wire, the fiber, or maybe the laser, radio wave, although it's what we call as a wireless. But the meaning of the physical path is that where do we want to send it, the message. So that's the gist of the physical path here. And then the protocol is the set of rules that govern the data communications. We can say that the protocol is like an agreement between the communicating devices, such that if you are using a different protocol to send an email, you may not have a correct or accurate message that will be translated later on. Okay, so that's the rules or uh the requirement for communicating in networks. Okay. Right. What are the types of data? Okay, we have text, we have numbers, we have image, audio, and video. But there's a combination sometimes, and then also there's a conversions of everything. But basically, this is the fundamental or the foundations of data that we have. So text is discrete because it can be represented as 1 or 0. Number also is discrete because you can represent it in bit patterns 1 0. But images can be composed of matrix of pixels, right? And this is also can be represented in a bit patterns also. Okay, so whatever images that we have, the network card is capable, should be capable of translating it into a bit patterns. But audio is a little bit different. It is a continuous data. It's a continuous data. Okay, consists of a recording or broadcasting. So such like this graph, okay, sinus graph, this type of graph. But video is continuous or can be a combination of continuous and discrete, because videos can include the audio, okay, and also an image, right? So image can be represented into by bit patterns, okay? So that's why. Now, what are the characteristics of effective data communication systems? It's like when they try to introduce the wireless at the time, what were the characteristic they want to introduce. So it means that they must ensure that the delivery must the function or the system must be able to deliver the data to the correct destination. And then accuracy, the system must deliver data accurately, such that it must ensure that if we are using a specific protocols, it must be able to translate it back, okay, and then ensure the integrity of the data itself. So that's why the system must be able to deliver the data accurately. So there's an error checking, okay. So timeliness is that, sorry, timeliness is the system must be able to deliver data in a timely manner. So some of the proposal of the system, the new technologies or the new systems must be able to ensure this timeliness. Okay. How long does it take? Okay. For the response, okay, to be received. So that's the thing that the like a programmer or developer have to consider about this. It's because of they need to consider also about the features or the performance of the network. Okay, so at the time, like a wireless. Okay, so what are the performance or on par the requirements that enable it to be deployed, okay, so that so this can be accepted by the user. Okay, so easy understanding, so the system must understand the data, meaning that you must have a protocol that enable you to understand that message. Okay, and then noise, so the noise is always there because of there's no perfect system. There's no perfect system in network. Okay, in the network domain, there's always a noise. Okay, but we must have a method to prevent the noise or reduce the noise. Okay, to reduce the noise. Okay, now what about data transmission flow? We have, okay, when you are connecting between two devices, okay, so there's a several types, several types of data transmission. We have a simplex, half duplex, and full duplex. So simplex is the communication that use a unidirectional, where only one of the two devices on link can transmit while the other is receive it. So for example, we have a server and monitor. So the direction is that only the server can transmit and the monitor will receive it. But this is the keys of this is like the foundation of it. So there's other applications or other systems that use this method, such as thin client. Okay, they use this kind of directions. Okay, data flows. Data flows. Okay, half duplex. This is applied in most of the communication system. Half duplex is that each device can both transmit and receive, but not at the same time. So at one time, the directions is from this workstation to the notebook, and then at time two, the direction of the data will be from the notebook to the workstation. So this is what we call half duplex. So one directions at one time. So what about full duplex? Full duplex use both devices can transmit and receive simultaneously. So for example, we use fiber that we have like two twin. It's like a twin cables, so that it will enable the transmission from both sides. Okay, so sometimes the meaning of the full duplex is that we say that it's a for it uses both directions. They can transmit and receive simultaneously. But sometimes the directions, these full duplex can be meaning such as we require one line of that can implement half duplex. Okay, and then another combined with another line to make it as a full duplex. So one directions using one line, and then another line is for another direction. Okay, so it can be both. So that's why I said before, um, the implementation for a full duplex can be costly. It's because of it requires a double, or the implementation a copy another one. Okay, uh, meaning that one cost for half duplex, but we need to increase the cost more if we want to use the full duplex. And then this is half duplex. Okay, sorry. Okay, so what's the difference between the half duplex and full duplex? Based on this meaning, you can just understand based on direction of data. So now, that is the data flow. Okay, now we continue with the data transmission. So data transmission can be divided into two categories. One is the parallel, and then one is the serial. Okay, serial is can be divided into synchronous and asynchronous. So what does it mean, serial? Okay, so serial is that one bit follows by another. So we have like a parallel or serial converter here. Okay, so and then one the communication line. Yeah, like our like your um cat 6 or your cable. Okay, your cable, a copper cable here, so can only send one bit at one time. So in this case, we need a parallel or serial converter where you would send 8 bits, okay, one after another. Means that you will send 0 1 0 0 0 1 1 0 one bit at one time. And then when it reach to the receiver, okay, so it will be combined back again, okay, by the serial or parallel converter, and then process it back again. Okay, so um under the asynchronous transmission, if I say if we say about asynchronous, okay, asynchronous means that we send one start bit 0 at the beginning and then one or more stop bits at the end of each byte. So means that there's a gap in between of the message. Okay, so let's say the directions is from the left to the right. So you will need a start bit 0 and then you start sending the data bit by bit. Okay, and then you want to tell, okay, this is the stop bit of this message. So you will send one bit or maybe more than one bit. And then there's a gap. Okay, after that, you send back again another batch of bits. So here we start back again 0, data, and also the stop bit. So this is what we call as asynchronous. So can you imagine why do we need? Can you imagine why we need to use the asynchronous? It's because of um you might have some intermittence, right? Okay, so you might have some intermittence. So you need to send back again the data. So uh asynchronous here helps, okay, to ensure that, okay, there's no error, okay, in between of the data, so that it helps to the receiver how to process it by identifying which one is the start bit and then there's a stop bit. Okay, but if it's a continuous or like synchronous, here, this one, this is like a synchronous transmission where we send the bits one after another without start or stop bits or gaps. So here, it depends on the receiver, okay, to identify this group of bits. Okay, so there's a disadvantage here. It's that sometimes the data will be distorted and the receiver might not know, okay, what will happen if the start bit become ones, what will happen. So the receiver might think that this is not a stop bit, but this is a data. Um so there's some mechanism happen during the transmissions, okay, so where we would come across on the OSI model. So each of these transmissions have their own advantage and disadvantage, okay. Now okay, and then parallel. Parallel. Okay, so this is a parallel. Parallel transmission means that we send a group of bits. Okay, we send at n bits at one time. Okay, using n communication channel. For let's say we want to send 8 bits, means that we must have 8 lines communication or 8 channels of the communication to be sent at one time. For example, when you are using a serial, sorry, when you are using a printer ports, okay, so they use a parallel transmission or parallel cable, so that it can transmit 8 bits at one time. Okay, so but in between the serial and parallel, the serial is much more cheaper and faster than the parallel one. It's because of the costing of using a serial is because they only need one channel, right? Compared to the parallel, which is you need 8 lines or maybe more than that, okay, for different type of parallel cables. So it will be more costly to manufacture it or to ensure that, oh, okay, if host A have a parallel wants to use a parallel transmission, it needs to make sure the other end must also have the capabilities to receive the parallel transmission. But serial can be said that it's a much more commonly used. For example, USB, what else? Our network Ethernet. Okay, so there's a lot of channels or communications or ports that use the serial transmission. Okay. List two different techniques in serial transmission and explain the differences. So here I have mentioned before what is under the serial is asynchronous and synchronous. So from here, synchronous and asynchronous. Okay, please identify what are the difference between the asynchronous and asynchronous and synchronous, right? So, next is protocol. So, as I mentioned before, the protocol is needed for you to communicate. Why? It's a set of rules or conventions that govern the all aspect of data communication. It defines what is communicated, how it is communicated, how do you want to communicate, and then when can you communicate. So the key element is that we need syntax or the structure or the format of the message that we need to send or communicate to the other end, and then the semantics or the meaning of the structure, and then the timing, when to send and how fast, okay, that you can send that message, right? Now, under the protocol, we have standard. Okay, so standard provides a model for development that makes it possible for a product to work. Depends on the manufacturers. So most of the time, the manufacturers will try to deploy or develop based on the standards that is available. So there are two types. We call it de facto or by fact, which is mostly used by or what we consider as industry standard, proprietary and non-proprietary. Okay, for example, EIGRP is a routing protocol solely or produced by the Cisco. Okay, so for each of the Cisco device, they are available to be used. So this is what we call as an industry standard by the Cisco, proprietary. But if it's a non-proprietary, so maybe we can use a BGP routing protocol so that for a different manufacturer, so you can communicate to each other. Okay. And then de jure. De jure is a legislated by official bodies. So something by law. Okay. In this case, for the data communication, okay, in between the bylaw is that you use the OSI and then de facto is TCP/IP. So most of the time for this subject, we would refer to TCP/IP. Standard organizations. Who should we refer? Okay, who should we refer for the standards? Okay, ISO or International Organization for Standardization is dedicated to worldwide agreement on international standards. And then we also have can refer to ITUT, which is International Telecommunications Union, related to the UN for telecommunications. There's a lot of technologies sometimes that we refer to ITUT. And then ANSI is American Standard National Standard Institute. It's a US non-profit organizations that represent the US to ISO and ITUT. So sometimes we refer to ANSI to communicate, use to base our communication system. So our keyboard is using the ANSI in standards actually. Okay. IEEE, Institute of Electrical and in Electronics Engineering. This is the largest professional society developing standards for computing, communication, electrical engineering, and electronics. So most of our communications hardware such as like wireless, Ethernet, okay, comes from standards, yeah? Standards for this cabling comes from the IEEE. Okay, so it's because of cabling requires the expertise from the electricals and also signals. Okay, so usually that's under the domain of Institute of Electrical. And then EIA, Electronic Industries Alliance, it's also a non-profit organization promoting standards for electronics manufacturing. Other government regulatory agencies such as SIRIM is from the Malaysian, And then that's it. Okay, for first part. Okay, I'll continue with day 1 to 2. This one, So I'll start with the networking model. Okay, so in these topics, okay, I would introduce about two models. One is OSI model, and then the second one is the internet models. So I state it as an internet model, but basically it's the TCP IP models. Okay. Now, okay, I'm I'm sure that some of the students have learned previously on data communications. Okay, so the OSI, okay, sorry, the protocols, the network models is needed, right, for you to communicate to each other. So in this case, the examples such as like sending a letter is that this is to tell you we have a division. Okay, there's a several divisions, higher layers, middle layers, and then lower layers. So for each of these layers, it has its own functions. Okay, and then it has its own protocols. Okay, that is needed to be confirmed. Okay, to from one end to another end. Okay, for example, for this letter, okay, we call it layer by layer is like a steps. Okay, like a steps, and then the letter is written, put in envelope, and then drop in mailbox. In this case, this is like an application. This is end user. And then what type of applications do you want to use? What type of formats of messaging that you want to write or you want to use for that applications? Okay, so it must be confirmed with the other end. Okay, must be confirmed by the other end so that it will be enabled to be able to read. Okay, and then understand the side also, when we go to the lower layer, the middle layer here, it's like a processing. Okay, it's like processing the messaging, okay, into something that can be converted, okay, and to the lower layers until it will be transmitted to the destination. Okay, here the letter is carried from the mailbox to a post office, and then the letter will be delivered to a carrier by the post office. The keyword here for the lower layers is that you must have a carrier, like a driver, someone who will deliver your message. Okay, and then so you can imagine what type of layers is under the lower layers. So mostly it's something that requires devices or messaging or cabling, okay, to transmit the information. And then we go back, process it, check it, okay, carry it to the post office, to the mailbox, and then pick up, remove from the envelope, and read it. Okay, so how many layers needed, okay, in our communications? So the analogy here is to represent, okay, the posting a mail, sending a mail based on the OSI layer. So this is the things. So for each layer, this one is application of the layer. This one, layer 6, is the translator. and then layer 5 is secretary, layer 4 is postmaster, and then layer 3 is where you need to address where to check it. Second layer is where to check it, and then you transport the mail. Okay, so there's an interesting part here. Okay, in between from the sender to the destination. So we have some like not flight delay, we what we call is like a transmission, okay? Where to stop. Okay, there's a stop here, there's a stop post here. So in between, for you to send from one destination to another destination, you need to stop from somewhere. So this is what I call as intermediary devices. So you need to stop somewhere to be checked and then process the addressing. Where do I want to send it? And then you send it back again, and then it will reach another stop, another station. So this station will check back again if this is the right route or direction. So you check the addressing and then go back and then transport it back again. So the processing of in between here doesn't take too much layers. It's because of they just need to check where to send. Okay, so is it the right route? So that's it. But when we reach to the edge or to the destination, then all the layers will be affected. Okay, will be affected. Okay, will be run layer by layer. Okay, so in this case, we are using OSI layer. Okay, usually OSI is Open System Interconnections. Okay, model. It's established in 1947. Comes from the ISO. Okay, ISO comes out for this network model. Okay, network model where it covers all aspects of network communication. So it was first introduced in the 1970s. Okay, then but at this time, TCP/IP already mostly used, okay, mostly adapted on most manufacturers. So they only reference it as a standard, but the implementation is mostly used by the TCP/IP. They use much more on the TCP/IP. Okay, but still I will explain also on this model. Now, as you can see on this figure, we have the network models. The network models, for example, whatever applications or methods or communication that you need to use, you still need to refer to the OSI model or the TCP/IP model. The gist or the concept inside of it is that each of these layers, between these layers, we have an interface like a middleware, okay, to communicate between these layers. Okay, so we have an interface between these layers until the end, or until it reach to the physical here. Okay, so from application to the physical. And then between layers to layers, we also communicate or confirm, okay, the same protocol is used. So this is where we say that peer-to-peer protocol. So means that if you want to use the HTTP, and then at the end of it, it must be capable of confirming or use the HTTP also. Okay, so let's say you want to use the TCP port, then the TCP also must be supported from that layer also, must be used. So this is for the peer-to-peer protocol. So peer-to-peer protocol happens from fourth layer until the seventh layer. Okay, and in between, in between the communication from device A to device B, okay, we would need an intermediary node. Okay, you will need an intermediary node. Okay, so means that the node here is only to check, okay, if this is the correct route for you to, okay, is this my message? And then I need to check, oh, okay, this is not for me, but only for me to direct it to another route. Okay, so that's what we call as intermediate node. So for intermediate node, it will only pass through 3 layers. Okay, and then go back down and then send it back again. If this is a intermediary node again, only 3 layers will be affected, and then go back until it reach to the edge network. So this is the end of the devices, or the destinations. Then it will go from the physical data link network until to the application. Sorry. Okay, so I will explain more about the functions. Okay, but this is like a the summarize. Okay, what is the OSI layer? Okay, and the for each of this layer, for example, layer 7. Okay, we call this information or messaging as data. Okay, as data. And then sometimes it will contain like a protocol such as www, FTP, chat. Okay, so all the things, all the applications would require some protocols that to communicate. Okay, so in this case, if you use mailing, then you need a protocol for the IMAP or POP3. Okay, and then it goes down to the presentation. So, does it need to have type of file types that need to present that data? So, for example, if this is a video data, then you might want to use the MPEG. Okay, and then if it's a picture, maybe JPEG or GIF. And then if it's a file, is it a DOC or TXT? Okay, and then if we go to the sessions, okay, here is like what does it do? So for example, if we are chatting or telnetting, okay, if you want to connect to a certain devices or network device, you want to use a telnet, then you need to open it first and then communicate or do something and then you close it. So this is what we call as a session. Transport is that based on your application. Based on your application, then you need to determine, is it a TCP or UDP? And then network, still we call it as a data. Okay, still we call it as a data. No, actually this is a frame. The data is encapsulated. I will call it as encapsulated. We transform it into bits and then encapsulate it to become a packet. Okay, here the protocol would be the type of protocol that should reach to the internet, right? So maybe you want to use IP or HTLC or IPX. And then data link. Okay, depends on the application that you, depends on the devices that you use. For example, if this is a PC, yeah, this is a PC, then your functions or this part on this layer would use an NIC, network interface card. Okay, here it will become a frame. Okay, where we have a header, we have a trailer to identify that frame. So once we transform it into bits, then we can transmit it, okay, using a signal specific to this physical. For example, if it's a copper, then it would be different. If it's a fiber, it will be different type of signals. Okay, so physical here is physical line or communication cables that we need to use, or maybe communication methods such as like a wireless. So in this case, the protocol would be what type of um, communication that we use. If it's a wireless, IEEE 802 dot something. Okay, so that's the the overall of this OSI model. Okay, so first is that the physical layer. Physical layer is responsible for transmitting data bits from one node to another, to the next. Okay, so this layer defines the rule by which one and zeros are transmitted. Okay, such as like when we want to transmit it as a 0 or 1, so usually we transmit it in a terms or in a method of voltages of electricity. And then on this layer also they will determine how much numbers, okay, the number of bits that we need to send per second, and then the physical format of the cables and the connectors used. If you are using Ethernet cables, then what type of end ports that we need to use, okay, so that it can suit to that computers. Okay, so this is the gist or the summarize of this physical layer. So it must determine the physical characteristic of interface and media, also responsible in representing the bits. Okay, how does from the previous one, okay, based on this type of physical cabling or media, how do you want to represent the bits? And then how do you want to determine the data rate, how fast you can send out? And then how you want to maintain the synchronization of bits. Synchronization here means that because of some of the end device is much more faster compared to another device, or maybe the other end or the destination is much more slower. So one is faster, one is slower. So by the time the destination who's received it, it cannot process it because of that's a lot of information. So usually for the physical layer, they have some mechanism how to slow down or to make sure that it is synchronized, the destination can receive it, okay, um without any collision, because of if it's too fast that will happen, okay, there might be collision happen during the transmission. Okay, so this is physical layer is the physical connections from start from the network interface card to the next network device. Okay. Now the data link layer manage the physical transmission circuit in layer 1. Okay. And transform it into a circuit that is free of transmission errors. So here, the keyword is transmitting frames from one node to the next. Its duties is that framing here is to convert, okay, to convert the previous layer, okay, starting from the packet, and then from the network layer here, okay, they would need to transform into a frame, okay, which where it comes from the word framing here. So the previous packet would be divided. We chunk it into a small portions of frames. Then it will contain some header and trailer, and then that data. Okay, so by this layer, so we can have like almost, okay, like a content of what would need to be transferred to the physical layer. And then on this layer also, they are responsible to process the physical addressing to determine, okay, where do I need to transfer this? Okay, it's based on the physical address that is on the header, received from the previous layer. So another one is that, so once you have determined, okay, so next, where do you want to send it? Now you need to determine the flow control. The flow control here is that it's like a communication. It's like a communication. Maybe you want to start, okay, I need to start first. I want to start sending, and then I will start to send one frame, second frame, third frame. And then I need to wait. I need to wait for the acknowledgement. So all your communications would need to receive an acknowledgement to know that that data has been correctly saved, correctly received by the destination. Okay. And then the error control usually contained on this layer also usually happens after the host or device receive it from the physical layer. So from the physical layer, the data that is contained or transmitted from the physical layer will be checked if there is any error bit. Okay, and then next is the access control. Here, it's not like the one in your database who can access it, who can, it's not that access control, but actually the way you access it, the way we maintain, the way we maintain the sequence of the messaging. Okay, so which one comes first? And then what will happen if a non-sequence messaging happens? So that's how we control it. Okay, so but then that is for the data link layer. Okay, so then okay, this is the data link layer where one of the example where we do the node to node delivery. We said it as a node to node delivery. It's because of here, as you can see, hop to hop or node to node delivery means that where is the nearest devices that I can send out. Okay, so the nearest devices must be on the same network. Okay, A and B here. Okay, you want to send from A to D or A to F. So you would need to send out not directly to that destination, but you need to send it using an intermediate system. Okay, so you need to identify, okay, the PC or the host or the end device need to identify where is the next gateway that I can send out. Maybe on the switch or also maybe on the router. Okay. So this can be a router. This can be a layer 3 switch. Okay. So in order to send it to the router, so it needs to have a physical address. Okay. This one, the physical address that is embedded on this device B. So first, the data has been transmitted, okay, and then go to the next one, which is the router, and then the router would and transform it into bit, and then they check on this data link on the header. Oh, okay, so this message should be sent to me as B, so I need to open it. Okay, I need to check it. Okay, I need to check it. Okay, so which next devices, the nearest devices for me to send out. So for example, A wants to send to F, for example. So B will need to decide, okay, is it C or E? Okay, so if it's F, then it needs to look at E, right? So it needs to have the MAC address of E. Then they will encapsulate it and then send it back. Okay, send it to the next destination. So at layer 2, it will be broadcast and not broadcast. Yes, it will be broadcasted, okay, because of um they don't have the directions, okay, they don't have directions, but in this case, because we have a router, so the packet will traverse on that specific route. Okay, and then they will check again. So E will check again and then say, oh, okay, F is on this link. So I would give you the F physical address inside of it and then send it out to the next device. So in this case, E here has been reached to the end. So it will send out to the devices. So here F will receive it. Okay, let's say on network in E, okay, has other devices such as GHIJ, for example. So it would be sent out because E already have, let's say E already have the address of F. So E can directly send out to the F. Okay. Now, example, a node with physical address 10 sends a frame to a node with physical 87. Okay, so when I say it physical means that this is not the same as the one on your layer 3, yeah, like 192.168.10.10, not that one, but this one is something like the one that we have, like this command prompt, and then when you try to do some IP config slash okay, you can see on the link local IPv6 address, so no, this one, sorry, let's look at the, okay, I do have a lot, okay, this one, Ethernet adapter. So my Ethernet adapter has a physical address, this one, 0A00270010. So this is the physical address that would be recognized by the layer 2. So but in this case, the example here wants to shorten it, they want to shorten it, so they just use 10 here. Okay, they use 10. And then okay, wants to send, okay, the destination is 87. Okay, wants to send to 87. So because of these nodes is connected by the same link, okay, it's connected by the same link, then we can just, on the header here, okay, the data link will contain the physical address in this header. It will contain the source address and also the destination address. Okay, as for the rest of the header, it will contain other information needed at that level lah. So the trailer usually contains extra bits needed for error detection. Okay, when it reach to the destination, then this error detection will be used to check. Okay, network layer. Network layer performs routing. It's responsible for the delivery of packets from the original source to the final destinations. So in this case, the final destination is something like this, Okay, this is the start, this is the end. So the layer 3 is responsible from the start until finish. But data link layer is only responsible to its nearest devices. So that's a difference. Okay, there's a difference between these two layers. So why do we need this network layer? It's because of you need to have the destination. You need to have where you want to send. Okay. As for the data link layer, is that who is the nearest station or stop that can help me send it to the final destination. Something like that. Okay. So in this case, for this layer, we need a logical addressing. Okay, the logical addressing to determine who is the sender, who is the final devices that should receive the message. Okay, so in this case, in order to ensure that the message can be received, this layer contain routing. They perform routing where is the device need to determine the best route through the network and finds the full address for that computer if needed. Okay, so in this case we use a packet delivery. Okay, hold on. Okay, here, as I said before, this is a source to destination delivery. A wants to send to F, right? So means that we need to have both the sender and the receiver address, okay, on that packet, so that we will know in between the message is sent in between on the intermediate system from A to B, B to E. So we need one directions where is the final destination, right? So that's why we call it as a source to destination delivery. So in this case, at the end system, okay, this is the packet and layer 3 is network layer contain packet. So the packet will process where should you send the final destinations. So it will contain that information. So they will send out and then to the next layer, which is the data link. So for this data link, you know the whole route. Okay, you know the route where you want to go. But then you need to determine which devices, okay, which node that I need to send that is the nearest to me. So that's why from A should be sent to B, then I need to process or have B MAC address. And then I need to add it on this layer. And then after we have confirmed the hop to hop delivery address, and also we have the source to destination delivery address, then we can convert it into bits and send it out. Okay, so by this time, when these devices receive it, they will check back. On the data link, it will check, is it confirmed to its own MAC address? So it need to check, okay, this is my MAC address. But then it need to check on the network, okay, this is not my IP address. This is not my logical address. So they need to process it back again, determine, okay, this is not mine. I need to route it. So which route that I need to choose? Is it to C or is it to E? So in this case, the IP address of the F contained under the jurisdictions of E. So they will need to send out to E. Yeah? So it would need to send out to the data link and then determine, okay, E MAC address is such, etc., etc. So they will include it on the header of the data link. Okay, and then transform it back again, change it back to the bits and send it back to the next one, which is E. Okay, E again, check. This is my MAC address, but this is not my IP address. But the IP address is, I recognize it. It's because of it's at F. So I would send back again, send out, change my destination MAC address to F, and then I would send it out to the network. By the time F receive it, F will check, oh, okay, this is my MAC address. This is my IP address. Then I will proceed to the next layer by layer. Okay. So, example. Let's say we want to send data from a node with network address A. Here, this one, on this left side. Okay, and then we have a physical address 10, also with the logical address A. So on the internet, in this part, and the data AP, A and P here is the logical address. They want to send it to P. So we need the final or the logical address of P here. So let's say we put a P on this logical address, and then the sender is A. So during this time, no changes happen on the network layer. Okay, so because of this is the final route or the final destination that we need to confirm. So and then but then you want to send out. You know that you need to send to P. So which one is the nearest? Okay. So it is because of P is located on a different network, we cannot use physical address only. So we need a universal addresses that can pass through the LAN boundaries. Here we use a network logical address. So here we use P. And then because of this is a different network, so the MAC address would be different. It's not 10 and 95 because this is consists of several networks that we need to pass through, and then we need to go out from the gateway. So here is 20, so you need to place it as 20. And then by the time it reach to 20, it will change. um the sender is 99, okay, because it goes out, it goes out 99. And then the next destination should be 33. It's because of we don't want to send it to H. We want to send it to N. So the destination MAC address should be 33. A and P doesn't change. And then by the time it reaches to N, it determines, okay, you want to send to P. And I know that address. So I have the MAC address, or I would change it to Z. Sorry, not Z, 66. 66, and then the destination's MAC address should be 95. So by this time, M received it, but it's not its own MAC address and logical address. So they will drop it. Only P would accept it. Okay, the others would drop it. Okay, so in this case, it check, oh, okay, this is my destination or my MAC address 95. And then when I open the packet, okay, this is my IP address. So then I will proceed to the next layer. Okay, what about transport layer? Transport layer is responsible for delivery of a message from one process to another. Okay, so it deals with the end-to-end issues such as procedures for entering and departing from the network. It establishes, maintains, and terminates logical connections for the transfer of data between the original sender and final destination of the message. So, it responsible in assigning the port addressing. Why? You at the same time, when you are trying to communicate, you can also, like say you use an email. Sometimes you would use at the same time you open the web browser. So to differentiate between emails and web browser, then you will need a port addressing. Okay, you need to have a port addressing to determine which applications that we refer to that message to. Okay, so when we receive the applications data, okay, when they receive the application data, okay, it will be segmented. We call it segmented, and then we chunk it. We chunk it, segment it into a small size. Okay, breaking the large data transmission into a smaller packet to ensure that all the packets have been received. Okay, so here we segment it into a small one and put a header. Inside the header, usually it will contain the port to refer, oh, okay, this is for port 80 for my website, HTTP. Okay, so and then for this small segment, we call this data. We call it from the previous application data. We segmented it. Okay, so this will we call what will be called as segments. So these segments will be sent out to the network layer. Okay, so by the time it reached to the final destination, okay, previously here P received it, right? So P will check back again. Okay, if the combinations of data, okay, if we is correct or not for a certain port. Okay, so here we do have flow control and error control. Okay, we do have a flow control and error control where error control means that they need to check again the content of the message. Okay, if it's correct or not, accurate or not. And then the flow control means that we do have segmented, right? So which sequence do we need to follow? So that's why they need to refer to the header. Okay, and then um, uh, after that, they can combine it back together, reassemble back again, and then forward it to the application layer. So that's why the connection control, the flow control here is very important. So let's say the segment B reach first. So what does it need to do? They need to wait. They need to wait, okay, until the first segment receive. Okay, then okay, they will rearrange back again. So the first segment has been received, the second segment has been received, and then they need to wait for the third segment. Once the third segment has been received, then they can combine it, okay, and send it out. So this is the flow control that is needed. As for the connection control, for example, if you use the TCP connections, so the TCP connections must have like a hello, hi, okay, like introductions. I need to connect to you, okay, and then you send a message, and then once you have done, you need to exit. You need to log out. So that is for the connection control, And then for the session layer. Okay, session layer is responsible for maintains, establishes, and synchronizes the interaction between communicating systems. Okay. Session initiation must arrange for all the desired and required services between session participants, such as logging on to the circuit equipment, transferring files, and performing security checks. So usually the sessions need to do some confirmation. You log in, and then when you confirm this is the right user, okay, then we can transfer the file. Okay, and then once we have done it, okay, we complete the transmission, then we terminate it. Okay, we end it. Okay, synchronization allow a process to add checkpoints into a stream of data. Why do we need to add checkpoints into a stream of data? To ensure that the receiver would know that there's a gap here. Okay, so this is a stop bit. Okay, I need to make sure it's synchronized together. Okay, so this is a stop. Okay, and then continue, and then continue. So and then synchronize back again. So this is like a stop bits, to add checkpoints so that we can synchronize with the sender. Okay. Last is the no, not last. Presentation layer. Presentation layer is responsible for syntax and semantics of the information exchanged between two systems. It must do some translations like emails. Okay, some of the contents, okay, may use a plain text or maybe HTML, so they need to do some translation. Or sometimes we use an encryption or decryption in our application, so it will happens on the session presentation layer. Okay, also the compression. So if you do some compression like a zip file, so they would reduce the bits first, and then after it receive back again, they need to decompress back again. Okay, lastly, application layer. Application layer is responsible for providing services to the users. So in this case, if you are software programmer, or if you are an end user, so your applications is on this layer. Okay, for example, if you use Outlook as a mail, then certain applications can be used, like mail browser also can, mail application also can, and then they would use some specific protocols. Okay, SMTP. And then file transfer, use FTTP, login, accessing www, we would need to use the HTTP, means that any applications that support HTTP, just like that. So we provide network applications like this. And then TCP IP. So I'll just summarize it. It's because of it's basically the same. Previously, contains 4 layers. Okay, but then to um they evolve it to become like five. Okay, to make it as five. So we have application, transport, and the network, data link, and physical. Okay, so basically the same. Because of actually the TCP/IP comes first. Okay, the TCP/IP comes first. So this is from the application layer, and then it will become a segment. Okay, on the transport layer. Layer 3 is packet. Okay, or network layer, and then this layer 2 is a frame. So where does the data unit come from? PDU comes from, it comes from the TCP/IP. And then the last layer is bits. Okay, data bits, and then we send out. So this is an exchange using the TCP/IP model, which mostly used by the manufacturers. Okay, so basically the functions is the same. The function is the same. They don't have a difference between the OSI, because they need to conform to the OSI. Only that the difference is that the application, presentation, and session is combined together on the application. So as you can imagine, if let's say we want to use the WinZip or WinRAR, so basically, it's an application itself, right? And you can do the compression on that application. So that's why, like I said before, the manufacturer mostly refer to the TCP/IP. When they build up that application, okay, they refer to that TCP/IP. So that once we send out, it should be able to recognize the next layer. They can confirm or transport, can send down to the next layer. Okay, so that is for the TCP/IP. And then this is applications protocols that mainly used in the TCP/IP model, also using OSI model. So applications here, application protocols here refer to the type of functions that you want to use. SMTP such as mail, FTP for file transfer, HTTP for web browser, DNS for you to use together with the HTTP, where you write it www.google.com, then how to translate it back. So that's the use of DNS. Okay. And then for transport, this would be explained in detail on the transport, where how do you segment it? Okay. And then how do you confirm, or how do you control the packets, okay, the segment, okay, to become a complete message. Okay, and then this is for the network layer. Previously on the TCP/IP of the fourth layer, we call it as internet. But then they divide it, and then they name it as a network. And network access is divided into two. One is software, which is the data link, and then one is the physical. So basically the same. Okay, so we did not manage to say finish the network concept here. Okay. So as for the network concept, I would like to add a new topic for this one. One is for the network topologies, and also new topologies or technologies on the network that I can introduce here. But this is a basic one. Okay, LAN, WAN, MAN, and then I need to show a little bit more lah about this. So we will continue on next week. Okay. So inshallah I'll complete it for this chapter. This part 1-3 together with chapter 2. Okay. So is there any questions? Is there any question? Kejap Stop sharing. Let me see the notes. Is there any questions?
Oh, no, thank you.
Oh, okay. All right. So for this recording, I will record it. I will convert it into YouTube. So please wait a little bit times, okay, for this to complete, and then I would inform you, okay, the video. As for the implementation, okay, I would update it first, okay, so that you may be able to understand it lah. Okay, you should be able to understand the implementation of this week, so that please understand which is which that you need to confirm, you need to attend. So as I mentioned before, let me share it. Okay, mana ni? Okay, hold on. So this one, sorry, salah. Okay, I would transform it back to the slide here. Okay, the correct one. Don't use the previous version. Okay, I'll change the date for you to check for the implementation for the lab. Okay, this one is wrong. Not wrong. I just want to update it back again. So give me time a little bit, and then you can refer it. Okay. So I just need to confirm with the other lecturers, Mr. Razi and also Dr. Zul. Okay, for them to confirm, and then I can update it back to you again. Okay, right? So please wait. If anything, any communications, if any information, I'll just post it on the WhatsApp. Okay, that's all. Kejap, stop sharing. Okay. So if there is nothing, if there is no questions, okay, I will stop this sessions. Thank you for listening. Okay, so next week, if I've managed to finish the time, I would add a little bit about a small module about packet tracer, because it was request by Mr. Razi for me to teach you. Okay, for me to teach you about how to use that packet tracer lah. Okay, so that's it. All right. Okay, inshallah, I'll see you next week. Okay, same time, same implementation. Okay, online. Okay, Assalamualaikum warahmatullahi wabarakatuh, and good evening to everybody. Thank you.
Thank you,
Waalaikumsalam.
madam. Thank you, madam.
Thank you, madam.
Waalaikumsalam.
Thank you, madam.
Thank you, madam.